Okay, in this problem something funny is going to happen, and we're being asked to classify this equation as conditional, a contradiction, or as an identity. We're going to begin by distributing on the left and combining like terms on the right. The left side of the equation becomes 12 minus 20n plus 1, and the right side is negative 20n minus 8. Let's combine like terms on the left. This is going to give us 13 minus 20n equals negative 20n minus 8. There's no change on the right hand side. And since we have negative 20n's on each side, let's add 20n to each side. The n's disappear from the equation altogether, and we have left 13 equals negative 8. This is a false statement. Therefore, this equation contains a contradiction. Now that is a description of the solution set, but it is not the solution set itself. We want to write the solution set as either the null set or we want to write the empty set as a way of describing the solution set. In this next problem, determine the restrictions on x. Remember when we were talking about the domain of a function, we cannot have 0 in the denominator. So in this case, we need to ensure that x plus 1 is not equal to 0, and we need to make sure that x minus 7 is not equal to 0. Solving each of these linear equations tells us that x cannot equal negative 1 and x cannot equal positive 7. Again, we have a rational equation, and we wish to clear the fractions by multiplying through by the least common denominator, which is 3t. In the first fraction on the left, the 3's cancel, so we have t times 1, which is t. In the second fractions, the 3 t's cancel altogether, and we're just left with the minus 4 that we see in the middle of the equation. On the right side of the equation, the t's will cancel, leaving 3 times 7, which is 21. Adding 4 to both sides, we find that t is equal to 25, and our solution set is 25. Now we've got a little space here, and I should have been mentioning all along that anytime we're solving an equation, we're finding the set of values which satisfy the equation. So we should be able to take this 25, substitute it back into the original problem, and verify that it works. So let's take the time to check this problem. When we substitute 25 in, we're checking, is 1 over 3 minus 4 over 3 times 25 equal to, question mark, 7 over 25. Anytime we are checking the validity of an equation, we use a question mark over the equal sign. What I want to do now is get a common denominator of 75 in all 3 fractions. Keep the question mark over the equal sign. In the first fraction, the denominator is getting multiplied by 25, so the numerator will also. In the second fraction, we already had 75 in the denominator, so the numerator will remain 4. And on the right, the denominator is getting multiplied by 3, so the numerator, 7 times 3, becomes 21. On the left-hand side, when we subtract, we find that we get 21 over 75, and that is equal to 21 over 75 on the right, and so the value t equals 25 checks in this equation. In this next problem, we want to first find the denominators in factored form. The first denominator factors into x minus 4 times x plus 2. The second denominator is the difference of 2 squares and factors into x plus 4 times x minus 4. And the third denominator factors into x plus 4 times x plus 2. Since this is a rational equation, we want to multiply through by the least common denominator in order to clear the fractions. The least common denominator here is the quantity x minus 4 times the quantity x plus 4 times the quantity x plus 2. In each fraction, when we multiply or distribute through by this least common denominator, two of these three factors will cancel, leaving one. Here we're going to have on the left 4 times x plus 4, because after we distribute through, the x minus 4's and the x plus 2's cancel, leaving x plus 4. Minus 1 times x plus 2 equals 2 times the quantity x minus 4. Now what we want to do is a little bit of distribution on each side. On the left, we're going to have 4x plus 16 minus x minus 2 equals the right side, which is going to equal 2x minus 8. On the left side, let's combine like terms. 4x minus x is 3x, 16 minus 2 is plus 14, and the right side remains 2x minus 8. Let's get all the variables to one side. Subtracting 2x on each side will give us x plus 14 is equal to negative 8. And finally, subtracting 14 on each side gives us x equals negative 22. So our solution set contains negative 22, which, if we wanted to go and substitute it back into the original problem, we would find is a true value.